Math 3, Spiral Formative, Unit 8, Module 4, Part 1. The first equation is a radical equation. You always need to isolate the radical first before you try to cancel out the radical. So in number 1, the square root is already all by itself on one side of the equal sign, so we can go ahead and dive into undoing the square root by squaring it. Whatever you do to one side of the equation, you have to do to the other side to keep it balanced. On the right side of the equation, the square root and the squaring cancel each other out. So you're just left with 12 minus x. Since we have an x squared term and an x term, we want to get everything on one side instead equal to 0 so that we can ideally factor and solve. So since the x squared term is already positive, I'm going to move everything to the left side of the equation to keep the x squared positive. So I'm going to subtract 12 from both sides, and then I'm going to add x to both sides of the equation. So I have x squared plus x minus 12 equals 0. Apparently that last bit of the x didn't write. So now it's a basic trinomial on the left side of the equation. So I'm looking for two numbers that multiply to negative 12, and those same two numbers have to add to 1. Because remember, there's an invisible 1 in front of the x. So positive 4 times negative 3 is negative 12, and 4 plus negative 3 is positive 1. So we're at the point now where we set each factor equal to 0 and solve for x. So we're getting negative 4 as one answer and positive 3 as our second answer. Now the thing that a lot of people forget, you have to check your answer to see if you have an extraneous solution. So in order to check, I'm going to do the negative 4 first. So I'm going to take negative 4 and I'm going to plug it into the original equation wherever I see an x. So then I get negative 4 equals, under that square root sign, the double negative turns into a positive. So 12 plus 4 is 16. And then the square root of 16 is positive 4. So negative 4 does not equal 4. So we're actually going to have to throw out the answer of x equals negative 4. It doesn't work. It's an extraneous solution. So then let's check the other one. Let's check x equals 3. So we're going to put 3 in for x in the original equation, and then let's see if it ends up simplifying down to being a true statement. And sure enough, it does. 3 equals 3. So yes, that's a true statement. So x equals 3 is an answer to the equation. Looking at number 2, when I look at my denominators, there's nothing to factor. If I was able to factor something, I would want to do that so that I could figure out my domain restrictions and my least common denominator a little bit more easily. So speaking of domain restrictions, if I set each one of those denominators equal to 0 in every single one, x cannot be equal to 0. Because if it was, that would make the denominators equal to 0, and when we divide by 0, it's undefined. So we want to say x cannot be equal to 0. As far as the least common denominator goes, I'm looking at the 4 and the 2. The least common multiple of 2 and 4 is 4. Remember, multiples are when you count by a number. So for example, multiples of 2 would be 2 times 1, 2 times 2, 2 times 3, 2 times 4, and so on and so forth. Multiples of 4 would be 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on and so forth. So the smallest multiple that 2 and 4 have in common is 4. Looking at the variables, each fraction has at least an x in it, and then this first fraction right here has an x squared in it, meaning we need to have an x squared in our least common denominator. Now we want to multiply every single term by the least common denominator in order to cancel out the fractions. So everything's going to be multiplied by 4x squared. And again, we're doing this because it's going to cancel out all of the fractions. So in that first fraction, the 4 and the 4 cancel out to 1. And then the x squared and the x squared cancel out to 1. So the only thing left is 3x squared minus 2. For the second fraction, 4 divided by 2 is 2, and then x squared divided by x is x. So there's a 2x and then the 5x plus 1. So this 5x plus 1 matches with that 5x plus 1, and then this 2x matches with that 2x. And then in our last fraction, 4 divided by 4 cancels out. X squared divided by x turns into x. So then we're left with an equal sign, and then x times x plus 2. And to help you kind of line it up again, this x is this x, and then this x plus 2 is this x plus 2. At this point, we're down to a regular equation with no fractions. So we're going to simplify. We're going to distribute to get rid of the parentheses, and then we'll just keep going from there. So we have 3x squared minus 2, and then 2x times 5x is 10x squared. 2x times 1 is 2x. And then on the other side of the equal sign, x times x is x squared. X times 2 is 2x. Since this equation has squared terms and x terms, we want to get everything on one side equals to 0 so that we can factor and go from there. So it looks like I have some like terms that I probably should combine first. So let me go ahead and do that. 3x squared plus 10x squared is 13x squared. And then this 2x I think is all by itself. And then this negative 2 is all by itself. And I'll just drag down the rest of the problem. And then now let's get everything on one side equals 0. So I'm going to subtract x squared and subtract 2x from both sides of the equation. And then we get 12x squared minus 2 equals 0. And then as far as factoring goes, it's not a trinomial, it's only a binomial. And whenever you're factoring, you always want to factor out a greatest common factor first if one exists. So since 12 and 2 are both divisible by 2, I'm going to factor out a GCF of 2, like that. Then let's set each factor equal to 0 and solve for x. So 2 equals 0 and 6x squared minus 1 equals 0. Well, that first equation, 2 equals 0, that doesn't make any sense. 2 does not equal 0. So just cross that out. And then this other equation, we're going to want to add 1 to both sides. Just because I can't factor that, so I'm going to just do solve by square rooting. So I'm going to add 1 to both sides. And then I get 6x squared equals 1. Let me slide that over here. So 6x squared equals 1. And then I'm going to divide by 6, and then we get x squared equals 1/6. And then to undo something squared, you have to square root. So we get x equals plus or minus square root of 1/6. And that is not a domain restriction, so then that should be our answer. Looking at number 3, solve the equation below. So it's already factored for us, so we'll just take each factor and set it equal to 0. So divide by 5 to get x equals 0, and then add 2 to get x equals 2. And then that last one, working alone, Ryan can clean 1 collaboration space in 4 minutes. So Ryan can clean 1 space in 4 minutes. Times x plus Juan can clean 2 collaboration spaces in 7 minutes. So it's the number of jobs divided by the time, and then the x is representing the time it would take for them to do it together, and then equals the total jobs. So together, how long would it take them to clean 10? So 10 would be the total jobs. So that's our initial setup. Again, I did number of jobs divided by time, times x represents the total time it takes them to do the work working together. plus number of jobs divided by time times the amount of time it takes them working together equals the total jobs. So now we just have to solve. So our least common denominator is 28, because 4 and 7, the least common multiple of 4 and 7 is 28. So we're going to multiply everything by the least common denominator. And then let's go ahead and do some cross canceling. So 28 divided by 4 is 7. So 1x times 7 is the only thing left from that first fraction. Looking at the second fraction, 28 divided by 7 is 4. So 2x times 4 is the only thing left from the second fraction. And then 10 times 28 is 280. And then we'll just solve like normal. So 7x plus 8x equals 280. 15x equals 280. Divide by 15, divide by 15. So 280 divided by 15 is approximately 18.67. We did not give you rounding directions, so I would really accept, 18.67, 18.667, 19. I'd accept all sorts of different things for this problem. I'm just going to leave it 18.67, but I really should add some units on here. This is the time, and the time was in minutes. So I'm going to add minutes onto the answer.